Hi everyone. So today we're going to work on operations involving functions. So we're going to be doing the add, subtract, multiply, and divide with functions. And we're going to look at how does that affect the domain of these functions, like putting them together, what happens. So at the end of today, we're going to hopefully be able to perform the operations on the functions and then determine the domain of these combined functions. So remember, a function is something that passes the vertical line test graphically. Every x has exactly one y. All the x's are different if we list them as an ordered pair. So it's a special set of ordered pairs in which every x is different. There's notation. We call it f of x. And there's also g of x and h of x. It's the name of the function. And when we evaluate g of 2, for example, that means substituting 2 into the expression everywhere you see an x. We spent some time talking about functions, but we're going to be spending a lot more time talking about it. So when you add, we can have it as f of x plus g of x. That just means add the two functions together. You're just combining like terms, things like that. Subtraction, you're going to subtract the two functions, but be careful to remember the negative sign, okay? The minus sign, the negative sign. Make sure it gets distributive and it's minus the expression. Multiplication, we usually write as f and g. Multiplying the two functions, we may have to do some FOIL, we may have to distribute, things like that. And division, when we divide the two fractions, divide the two expressions, the functions, we may need to factor, we may need to rationalize the denominator, we may be doing a whole bunch of stuff with division. Again, division always seems to be an issue. Okay, so let's start out with these two functions. F of x is equal to x squared minus 9, and g of x is equal to x plus 3. So we have f plus g of x. This is also can be written as f of x plus g of x. So in other words, we can just add these two functions together. So we're going to do x squared minus 9 plus x plus 3. Okay, so we're going to combine like terms, and that's it. Okay, so we're just adding the two expressions together. So here we have f minus g, so that can be written as f of x minus g of x. Okay, so we're going to take f of x, which is the x squared minus 9, and subtract x plus 3, so we get x squared minus x minus 12. Okay. All right, so when we multiply, so again, this could be written as f of x times g of x, and we're going to do x squared minus 9 times x plus 3. Okay, we're going to do some FOIL. And that's it. Okay. All right, so let's do f divided by g. So we get x squared minus 9 over x plus 3. Now, we know that x squared minus 9 can be factored. So let's see if we can reduce this fraction. Oh, look at that. Oops, it should be 3. All right, so notice that both x plus 3 is in the top and the bottom, the numerator and denominator. So we can just reduce those out. It's like taking 2 over 4 and dividing both 2 and 4 by 2 and getting 1/2. We're going to work on that in a little bit more. We get x minus 3. All right, so hopefully it doesn't seem too complicated. We're just going to add our two fractions, subtract them in the order in which, again, there's a big difference between f minus g and g minus f. Okay, multiply and divide. So why don't you pause the video and try number 2 on your own. Okay, so here's our answers for number 2. Okay, notice in the division 2x squared plus 8 cannot be factored, so we're just going to leave it just like that. Okay, so it doesn't seem too difficult, but what we need to talk about is the domain. Okay, so domain, remember, is x. Domain is the values that we can put in for x. Okay, so we need to remember that. let's say values that can be used for the x value, input value. Okay. Now we did work on domain and range when we did quadratics a while ago, and we didn't really do anything with polynomials with that, did we? Domain. No, we didn't list the domain and range. But we did talk about turning points and things like that. So let's talk about domain with our operations. And here's the thing. For the addition, the subtraction, and the multiplication, the domain is just the domain of the two functions together. So the domain of the two functions. So if one of the functions happens to be a fraction, we would include that in the domain of the adding and subtracting and the multiplying. Division, as always, is a problem child, f of g of x, or g divided by f. The domain is what the denominator cannot be 0. So the domain has to be concerned about where the denominator is equal to 0. Remember, you can't have 0 in the bottom of a fraction. Okay, so let's kind of look at that in our first problem up here. Okay, in both A, B, and C, okay, we're going to look at the domains of f and g. And if we look, f is all real numbers, and so is g. So the domain of the add, subtract, and multiply is going to be all real numbers. Okay, so let's write that. F plus g, f minus g, and f times g. The domain is all real numbers because that's the domain of f and the domain of g. Remember, you can write it 3 different ways. You can write it out. You can write the funky r, and you can write it with from negative infinity to infinity in the interval notation. But the f minus divided by g, okay, is about g divided by f in this particular problem. Let me fix that. There's a big difference between that. Okay. All right, so we have to take a look at where is 4x plus 7 equal to 0. Oh, wait, wrong, sorry. That was problem number 2. Before we divided, we have to look at where is x plus 3 equal to 0. So we can agree that it's going to be all real numbers. X cannot equal negative 3. Because here, that would cause the denominator to be equal to 0. All right, why don't you try number 2 with the domain and range. Okay. All right, so here's what I came up with. I've listed them all individually. All real numbers for A, B, and C. And again, you can do the funky R in the interval notation. But for D, I have all real numbers except negative 7/4 because negative 7/4 is what number would you put in to put that to equal 0. And I did, 4x plus 7 equals, and then solve. Okay? All right, so why don't we try these two? Okay, so we're going to do f plus g of x, which is the same as f of x plus g of x. Okay. So that's going to be x minus 3 plus the square root of x plus x. All right, so we're going to combine some like terms. We're going to get 2x minus 3 plus the square root of x. And the order really doesn't matter, okay? Because remember, the order in which we add things or add things or multiply things doesn't matter. Then we're going to do f minus g, and then we'll look at the domain. So remember, that's the same as f of x minus g of x. Okay, so that's going to be x minus 3 minus the square root of x plus x. So the square x is canceled out. We get negative 3 minus the square root of x. All right, so our domain, remember, is the domain of the individuals put together. So F is all real numbers, but G is all real numbers but 0. So our domain is going to be all reals. X cannot equal 0. And the same over here. Okay. All right. Oh, no, wait, I am sorry. Not 0. It has to be greater than 0. All right, because you can't have negatives underneath the square root sign. Sorry, I was thinking of something else. I don't know why I was doing that. All right, let's try this one. We're doing division and multiplication. So we're going to do f of x times g of x. So we're going to do 3x squared minus 11x minus 4 times 3x plus 1. All right, we got a lot of x cubed. It's 3x squared minus 11x squared plus 11x minus 11x. Okay. Minus 12x minus 4. 3x cubed minus 8x squared minus 23x minus 4. And then f over g. Okay, so 3x squared minus 11x minus 4 over 3x plus 1. Let's see if 3x plus, let's see, yes, he does factor. Let's see if it factors to this. Yes, he does. Okay, so my answer is x minus 4. Our domain, let's check our domains here. It's going to be reals, but x cannot equal negative 1/3 is because what the denominator, this guy right here. Okay, you can't do it after, you have to do it before because he's still not part of the domain. Domain here is going to just be all real numbers. All right, let me know if we have any questions, guys. Please stay safe out there, and I'll talk to you again real soon.